Hello, today's video is going to cover a review of exponent rules. You do have a copy of this graphic organizer posted on Google Classroom that you can access as well. So you do need to take these notes and remember these exponent rules because we will be using them throughout this unit. So when we talk about exponent rules, this is how we can combine different exponential expressions through what we call the product rule, power rule, quotient rule, negative exponents, and zero exponent rule. We're also going to talk about what's the difference between using exponent rules to combine exponential expressions and what it means when you combine like terms. So remember that like terms have the same variables raised to the same exponent, so the same combination of variables and exponents. When we talk about combining like terms, we add or subtract what we call the coefficients, which is the numbers in front of the variables. It's under adding and subtracting monomials, and they're called monomials because each one is one term. And just to clarify, because I noticed some people having difficulty with this, when we talk about a term is something that's separated by a positive or negative sign. So 9x squared y is a single term. Negative 10x squared y is a single term. They're separated by a minus. A division symbol or a fraction does not create a new term, just so you know that. Okay, so combining like terms, we simply combine the coefficients, but we do not change the variable expression, so we do not change our exponents. So for this one, you have 9x squared y minus 10x squared y, which is negative x squared y, or negative 1x squared y. Part 2 says subtract 6w from 8w, so you would go 8 minus 6, which equals 2w. Since it says subtract 6 from 8, so you would take 6 away from 8. Okay, so on combining like terms, we do not combine the exponents. But there are rules where we do combine the exponents, and those are called product, power, quotient rules. And in those rules, the reason why we can combine the exponents is because we're actually multiplying two exponential expressions together, or dividing two exponential expressions. But they're not separated by a positive or negative sign. Okay. So the first one is the product rule. And what the product rule tells us is when you have two exponents with the same base, which is the same big number, you can combine them by adding the exponents together. So x to the a times x to the b becomes x to the a plus b. Okay? So what that means is h second times h to the sixth would become h to the eighth. Because 2 plus 6 is 8. Now on the bottom, we have a couple different things going on. First of all, you have coefficients. So big numbers get multiplied together. What's negative 2 times 7 would be negative 14. And then we also have variable expressions. So a to the second times a to the third. So that becomes a to the fifth because we add the exponents together for that. And then you're going to combine the b's. You have b to, remember this is to the 1, b to the 1. 1 plus 1 becomes b to the second. If there is not an exponent there, it's an understood 1. Okay. So product rule, the way you can tell it apart is you have base exponents. You have a big number and then a little number times another big number and another little number. So two separate bases. Now the power rule is different. The power rule tells us when we take an exponential expression and we raise it to a new power, we can combine them by multiplying. A times B. And you can recognize this between the difference between this and the product rule is because the power rule, you have an exponential expressions inside parentheses with a new exponent on the outside. So let's look at problem 1. Problem 1 says x squared to the third power. So here you're going to multiply 2 times 3 and you're going to get x to the sixth. Now problem 2 is a little more tricky. Problem 2, you have two steps you have to do to solve this one. You have negative 2m to the fifth squared. So the first thing you do is you're going to square negative 2, which becomes positive 4, because negative 2 times negative 2 is positive 4. So any coefficients get raised to the new power. And then for m to the fifth times 2 becomes m to the 10th, and then times m to the third. And this is like a separate part of the problem because it's separated out. It's not within the parentheses. Okay, then now that we have this expression, we're going to use the product rule to combine. So 4 times 1 is just 4. 10 plus 3 becomes m to the 13. So your final answer is 4m to the 13. Okay, quotient rule happens when you divide. And in quotient rule, you're actually going to subtract your exponents, and you always subtract the top minus the bottom. So x to the a over x to the b becomes x to the a minus b. We would subtract our exponents. So if we look at problem 1, the 27 over 42 is just a fraction. You're going to simplify it like you would any other fraction. So 27 and 42 can both be divided by 3, and it becomes 9 over 14. For the x's, you've got 5 minus 1, so that becomes x to the 4th, and it goes up in the top. Let me rewrite that a little bit cleaner. So it's 9x to the 4th over 14. And I got the x to the 4th by subtracting 5 minus 1. I got the 9 over 14 by reducing 27 over 42. Okay, problem 2, you actually have to simplify first. So y to the 2nd squared, you're going to use the power rule first, and you're going to do that as y to the 4th. And then on the bottom you have y to the 4th. And then you're going to subtract 4 minus 4 is y to the 0, which then we'll learn about later, but that actually equals 1. And the reason why it comes out to be 1 is because anything divided by itself equals 1. Okay, negative exponents are kind of funky. You may have heard to flip the exponential expression if you see a negative exponent. But what I really want you to think about with negative exponents is that your exponential expression is in the wrong place. It's not happy. So x to the negative a becomes 1 over x to the a. So you take the exponential expression and you move it to the bottom. Now, if there is a coefficient in front of the exponential expression, it does not move. It stays where it is, and you only move the exponential expression. So, problem 1 says negative 5x to the minus 2. So the negative 5 is going to stay on the top of the fraction because it's a coefficient and it's not part of the exponent. And then you put x squared on the bottom. You'll notice that nothing changes sign except the exponent, and the exponential expression moves to a new location. Okay, problem 2 is a little more complicated. It gets into the quotient rule again. So anytime you're faced with something like this, you want to combine as much as you can. Remember that 4 over 8, you reduce it like a fraction to 1 over 2. And then k2 over k5, you're going to subtract 2 minus 5, and you're going to get k to the minus 3, which goes in the top. Now, correct answers never have negative exponents in them. So you're going to take that k to the minus 3 and you're going to move it to the bottom. So you've got a 1 on the top, and then you get 2k to the 3rd on the bottom. Okay, the last rule is the 0 exponent rule. Anything to the 0 power always equals 1. And it doesn't matter what that thing is. So it could be x to the 0, it could be 10 to the 0, it could be 1,000,000 to the 0. Anything to the 0 power equals 1. Now, that doesn't mean that number 1 in the examples comes out to be 1. So this one says 7x to the 0. That's like 7 times x to the 0, which is 7 times 1, which then comes out to be 7. So the exponential expression part gets changed to 1, but the 7 does not. Okay? Remember, the exponents only apply whatever is right next to them unless there are parentheses, and this doesn't have them. Okay, problem 2 is an awful lot like problem 2 up on the quotient rule part. So the first thing you want to do is apply the power rule. W to the 4th squared, so that becomes w to the 8th. Put w8 to the bottom. 8 minus 8 equals w to the 0. And then anything to the 0 power equals 1. Okay, so you're going to want to write down these rules, review them, and remember them. So they are really important. And then I'm going to continue this video and and we're going to do a few examples. So I'm going to do 3 or 4 different examples. The 13th. Okay, so how do we apply the rules? Now, when it comes to exponent rules and applications of exponent rules, the order doesn't necessarily matter. There's certain things you have to do first, but you can make some choices. And there's multiple ways to work some of these problems. So if you find a way that gets you the correct answer, that's fine. It doesn't have to be exactly the way I do it, as long as you apply the rules correctly. So first example is going to be 5x squared times negative 7x to the 6th. So this one, straight up product rule, multiplying things together. So you're going to multiply the coefficients. 5 times negative 7 is negative 35. And then for the exponents, you're going to add them together, and you get x squared times x is 6, so 2 plus 6 is x to the 8th. Okay, so that one's a product rule. Example 2. This one involves some powers and some product rule. So this one says negative 2a to the 3rd b squared times 8ab to the 9th. So this is one of those cases where you have to do exponents first, just like we do with the order of operations. We're going to go and we're going to square everything on the inside. So negative 2 squared, if you type that in your calculator like this, becomes positive 4. Okay? And then a, so you have a positive 4. A to the 3rd squared, so 3 times 2 becomes a to the 6th. B squared squared, 2 times 2 becomes b to the 4th. And then times 8ab to the 9th. So we've gotten rid of the parentheses. Next, we're going to use the product rule. 4 times 8 is 32. For the a's, it's 6 plus, remember that's an understood 1, so 6 plus 1 is a to the 7th. For the b's, you have 4 plus 9, which is b. Okay. You know when you're finished, when you can't simplify anymore and you have no negative exponent. So all your coefficients have been simplified as much as they can or put together. All your variables have been put together, and you don't have any negative exponents in your answer. Also remember, if you have an a and a b, those can't go together, so you keep those separate. Okay, let's do another one where we involve some quotient rule. So quotient rule example. This one says 54m to the 6th n to the 4th divided by 3m squared n. Remember on the bottom, this is like, if it's just n, it's like n to the 1. So I'm going to go ahead and put a 1 in there. You don't have to put the 1 in there, but I like to. Okay, so the first thing you're going to do is you're going to simplify the coefficients. 54 divided by 3 is 18. So if you have numbers like 54 over 3, you just type it in the calculator and get your simplified answer. Then for your exponents, you're going to subtract. So for the m's, you have 6 minus 2, which is m to the 4th. For the n's, you have n4 minus 1, which is n to the 3rd. I have no negative exponents. Nothing else can combine, so I know I'm finished. Okay. Sometimes we do get answers with negative exponents, so let's do another quotient rule where we would have a negative exponent. This one is 15x to the 10th y to the 4th over 24x to the 12th y to the 3rd. So first thing you're going to do is you're going to simplify that fraction. 15 over 24 becomes 5 over 8. Okay? Then we're going to subtract our coefficients for each letter. So for the x's, you've got 10 minus 12, which is x to the minus 2, and you put the answer on the top. And then for the y's, you've got 4 minus 3, which is y to the 1, or just y. Now, x to the minus 2 is a negative exponent, and it is unhappy. So the last thing you got to do is you got to take that negative exponent and you got to move it. So you get 5y over 8x squared. You'll notice the 5, the y, and the 8 did not move because they were all happy. We only moved the one that was unhappy. Okay, my last two examples are going to involve some power rule, and they're going to be a little more complicated. So, let's see, what are we on? Example 5. On this one, there's a couple ways you can approach it. But I think it doesn't really matter that much. Okay, so this one says (14w12) over 7w to the third to the negative 1 power. Okay, so I can simplify the stuff inside parentheses first and then raise it to the negative 1, or I can raise them all to the negative 1 and then simplify. I'm going to simplify first. It doesn't matter, except it just seems like less work to me. I like to simplify if I can. 14 divided by 7 is 2. For the w's, we're going to use the quotient rule because it's division. 12 minus 3 gives us w to the 9th, then to the negative 1 power. Okay? Now, this is one where you have parentheses. The negative 1 is going to move everything to the bottom. So it becomes 1 over 2w to the 9th to the positive 1, and then multiplying by 1 doesn't change anything, so it becomes 1 over 2w to the 9th. And where negative powers just moves it down. And because it's a 1, we don't actually have to multiply it out. You could have multiplied it out first or switched it over first and then applied the quotient rule, and it would still work. Okay, last example, and this one has some fractions involved, so it's going to be fun. Example 6. We're going to use some power rule. We're going to use some product rule. So this one says 2/3 r to the second s to the 7th all to the second power times 1/6 r to the third, that's a 6, not a b, s. So first thing I'm going to do is I'm going to apply the exponent here, this to the squared. Okay? So what this means is we're going to take everything inside and raise it to the second power. So 2 to the second becomes 4. 3 to the second becomes 9. So since those are coefficients, you just calculate them out. For the variables, r squared becomes r to the 4th. 2 times 2 is 4. S to the 7th squared becomes s to the 14th. 7 times 2 is 14. And then times 1/6 r to the 3rd s. Now we're going to multiply out the fraction. So 4 over 9 times 1 over 6 becomes 4 over 54. For the r's, you got 4 plus 3 becomes r to the 7th. For the s's, you got 14 plus 1, which is s to the 15th. This time we're adding instead of multiplying because we're multiplying exponential expressions together, which means you add your exponents. Last thing you need to do is check and see if you can reduce your fraction, and we can. 4 over 54 reduces to 2 over 27, and you still have r to the 7th, s to the 15th. And I know it is correct because I have no negative exponents. Okay, so you do have a delta math that goes with this. It's a long assignment. You have until Monday to complete it, so take your time with it. Watch the videos within delta math. If you have questions, email me. Tomorrow you are going to have a short quiz, 20 questions, but it's multiple choice on quizzes over polynomial vocab. And I'm going to go ahead and get that posted today, so if you want to take it early, you can. And then hopefully Monday we will be back in the classroom.